A lot of what I'm going to say is not new to any of you. So it's just a way of looking at malnutrition from a totally, not a totally, but a different perspective. Let's say my perspective. You were told that I come from Gaborone. Indeed, I do. And this is the main building of the Botswana Baylor Children's Clinical Center of Excellence, where Jerry and I work and have been working for the last 10 years. So this is what I intend to talk about, just looking again at what malnutrition is. I mean, I think malnutrition is so important. It's worth revisiting that definition and trying to explain the long-term consequences of malnutrition using Judy's story. And if you think about your own practice, I think you're going to be able to identify who Judy is. Talk a little bit about the Barker hypothesis, and then offer some concluding remarks. So the definition of malnutrition to dietitians, this is they're talking to the choir, but I think it's worth just worth remembering that it is a condition that develops when the body does not get the right amounts of nutrients, vitamins, minerals, and carbohydrates that it needs in order to maintain healthy tissues and organ function. And it encompasses both undernutrition and overnutrition. All ages are affected, although the majority of those who suffer from this, except in times of stress and large population displacements, are children. And this is the map of the world as we know it, as is often displayed. It doesn't really look like this, but just remember these normal shapes as we move along. But when you consider iron deficiency anemia, the map of the world is totally distorted. And as you can see, iron deficiency anemia is essentially a problem for Asia, especially India and Africa, although it affects every part of the world. If you look at underweight in children, more or less the same picture, although South America and the Americas essentially disappear. But it's essentially a problem of Africa and Asia. And so, if you look at the global prospects of diet and disease, the WHO estimated that by 2020, 2/3 of the world population will be suffering from chronic non-communicable diseases, which are most strongly associated with diet. In other words, as we move towards the future, diet and what we eat is likely to determine what we will be dying from. And that's going to be mostly non-communicable diseases. So what's the impact of malnutrition on people? Essentially, the impact varies according to severity and duration. It also depends on one stage of growth and development. So that in adults, malnutrition normally results from specific organ dysfunction, while in children, it affects their physical and mental growth. But in the fetus, it affects all cells, all organs, and all growth. In fact, it affects the whole body in its totality. So the impact of malnutrition, therefore, is most severe when it affects the fetus. In some children who are impacted by malnutrition, it leads them to die from that. And according to WHO, 56% of all deaths among children aged 6 months up to 5 years are attributable to malnutrition. So malnutrition is a very important contributor to child and infant mortality. And 83% of all deaths are attributable to mild to moderate malnutrition as opposed to severe malnutrition. And this is simply because severe malnutrition affects only a small proportion of patients. Mild to moderate malnutrition affects the majority of children whose immunity is then compromised and leads a large number of them to die. So moderate malnutrition in terms of mortality is much more important than severe malnutrition, although we tend to focus more on severe malnutrition. So if you look at, for example, vitamin A-related deaths, one would think this monster here, Africa, is where, and India is where almost all the vitamin A-related deaths occur at the moment. And the rest of the world is kind of stringy, it kind of disappears. If you look at early neonatal deaths, a lot of which are also influenced by malnutrition during the intrauterine life. Again, yes, you can see from this map, it's essentially a problem that affects us, although South Africa is kind of the smallest part of Africa. It is not as distorted as the rest of it, but still it is there. The same applies to infant mortality rate. And if you consider under 5 mortality, the map of Africa is even worse. It's almost circular. So, some children die. And so what happens to the survivors? So the survivors, the impact may be lifelong and may be seen for very many generations. And this is the concept that malnutrition affecting children can actually affect several generations. It's a relatively new concept. So the remainder of this talk, I'm going to focus on the survivors, because this is what we see in real life, since those who are going to die have already died. And so I'm going to focus a little bit on the intergenerational impact of malnutrition. And to help us understand this, I'm going to tell you the story of Judy. And I'm going to tell you Judy's story slowly because I want you to understand Judy's story. And then I'm going to review the evidence from some animal studies and the back hypothesis. So let's look at Judy's story. Judy and her sister Jane, Judy and Jane, were born at term, but their birth weight was only 2.1 kilograms. This is a real story. Like their mom, Judy and Jane are short, with heights of only 1.2 and 1.1 meters. However, their dad was a very tall guy, weighing standing 2 meters high. Judy marries a tall lad too, like daddy. But her firstborn baby weighs only 1.9 kilograms. So the firstborn baby does not represent the size of the dad. And Judy's mother, who had suffered a stroke at the age of 49, comforts her daughter saying, "Don't worry, my daughter. The baby will grow. Even I was born small." So you see here we have the grandmother who was born small, who is small. She has 2 daughters who are small, and one of the daughters has a child who is also low birth weight. Judy's older sister, Jane, attended boarding school, while Judy had not attended boarding school. In fact, she used to walk many miles to school and remained rather thin, slim throughout her life, even during her pregnancy. And during boarding school, Jane gained a lot of weight. She was not given to doing any physical activity. She liked her food, and she became relatively obese with a body mass index of 33. During her pregnancy, Jane was modestly hypertensive, but when they checked her glucose tolerance test, it was normal. Jane had a firstborn child by cesarean section at term, and the baby was weighing 4 kilograms. So, what are the findings from animal studies? Remember Judy's story, Judy and Jane, but let's just talk a little bit about animal studies. Research in rats, and one may argue that rats are different from us, but there are a number of fundamental biological systems which unite us with animals, lower animals, if you like to call them lower animals. But studies have shown that mother rats which eat an unhealthy diet during pregnancy may be putting their own baby rats at risk. And that depending on timing, malnutrition in rats leads to restricted growth in the fetus, leading to small for gestational births. And because we share a lot with animals, this would suggest that the same would happen to us. That's where D.J. Barker comes in. And what he did is to do in humans studies similar to those that were done in rats. I mean, look at humans specifically. Specifically, he found that a growth in utero predicts blood pressure in childhood and adult life and mortality from cardiovascular diseases. So it was Parker that put this on the agenda. He studied a lot of people, almost 10,000 10-year-olds and 3,000 adults in England and Wales. And he chose people who had had complete birth weight data for his study. This slide summarizes the main findings that Barker published. The key findings are that systolic blood pressure was inversely related to the birth weight. So in other words, the lower the birth weight, the higher the blood pressure was going to be when that child survived into adulthood. And this association was independent of gestational age and therefore could be attributed to reduced fetal growth. And he also found that 10-year-olds living in areas with high cardiovascular mortality were shorter and had higher resting pulses rates than those living in other areas, and that their mothers were also shorter and had higher diastolic blood pressures. And therefore, these findings suggested that there was something persisting, that there are persisting geographical differences in early childhood environment that predispose to differences in cardiovascular morbidity and mortality. So Barker then formed what has now come to be known as the Barker hypothesis. And essentially, the Barker hypothesis of fetal origins states that fetal undernutrition in middle to late gestation leads to disproportionate fetal growth and programs for later coronary heart disease. So people who are dying from coronary heart disease in their 60s were most likely programmed to die when they were still in their mother's wombs. The BRCA hypothesis has since been confirmed in very many human studies. So then, how do we explain the BRCA hypothesis? And this is where epigenetics comes in. Epigenetics is the study of heritable changes in the gene expression, which is caused by certain mechanisms without changes in the underlying DNA. So the DNA does not change. The genes themselves don't change. And yet the way the genes themselves express in the phenotype changes. And these changes may persist through cell divisions for the remainder of the cell's life, and then may also last for multiple generations. And epigenetics, which is a relatively new science, therefore explains what BRCA hypothesis observed in epidemiologic studies. And that's really the basis of the long-term consequences of malnutrition. So, that therefore, non-genetic factors, environmental factors, and when you think about the environment, you think about the gross environment outside and the microenvironment, which is closer to whatever you are looking at. That these environmental factors, which are non-genetic, can cause genes to express differently. And the nutrient environment in utero is believed to act this way to cause what has been termed nutrient-mediated teratogenesis. So this slide more or less summarizes. So if the mother is unable to supply nutrients to satisfy the fetal demand, you get fetal undernutrition. The kidneys are smaller, a smaller number of nephrons. The liver cells, the liver itself is smaller with altered insulin sensitivity. The pancreas has fewer beta cells and less ability to secrete insulin. The muscles and bones are less in quantity, and there is increased fat and reduced insulin sensitivity. And the brain is usually much smaller than it should be, and it affects the appetite. And the hypoxis pituitary adrenal axis is also affected in such a way that there's increased cortisol and early maturation, which then lead eventually to hyperlipidemia and hypertension, central obesity, insulin resistance, type 2 diabetes, and cardiovascular disease. And this double trouble, it can be expressed differently in this slide. So if we have a short, malnourished mom who most likely herself was born small for gestational age with low birth weight, you get a thin, fat baby. And the thin, fat baby has three possible ways. If the baby survives, if it remains malnourished and thin, then it's going to grow into a malnourished and short mom who then will have small gestational babies. If this baby lives a healthy life and grows into a normal baby, you have a chance that you could begin to change what had been programmed through the process of epigenetics towards normality. On the other hand, if the baby catches up weight, so it becomes obese on the background of low birth weight, then they end up with obesity and the consequences of that. Here we have a mom whose environment has too many nutrients, who has a very fat baby, macrosomia, at birth, if that baby continues to feed unhealthily and remains obese, it ends up here. So the only way to deal with this is to ensure this baby never becomes obese in their childhood or adulthood, and then you have a better chance of beginning to deal with changing the expression of genes by altering the environment around the genes. So with this explanation, can anybody explain Judy's story? I see a lot of nods, but nobody's putting up their hand. So let's explain it to you very quickly. I think you know the answers already. So Judy's mom had been a low birth weight baby, and she in turn gave birth to 2 low birth weight babies. Judy's mom also suffered a stroke, which is a cardiovascular event, at the age of 49. Judy likely suffered from cognitive dysfunction and so did not achieve her full genetic potential. And she was already married at the age of 19 because she did not progress very much in school. Judy's sister, who was low birth weight baby, gained excessive weight in school, developed gestational diabetes, had a macrosomic baby, with all the risks pertaining to such babies. So in view of the fact that we have a lot of malnutrition in our environment, a lot of stunting, a lot of low birth weight, and so on and so on, do we have hope? Is there anything that we can do? I believe that if you look at Judy's story, the grandmother is more or less a lost cause. One can attend to her problems, but one cannot completely prevent them. But we have a chance to start with the young ones by helping to retune their current epigenetic modifications towards normality through our own interventions as dietitians, as pediatricians, as public health specialists, and so on and so on. So, and in order to do this slide was shown by Anne-Marie the other day. A large number of players is going to be required. You're going to require governments to do their job. You're going to require professionals to do their job. You require nutrition-sensitive programs, and so on and so on. All these impacting through a number of activities in order to optimize fetal and child nutrition and development, and therefore eventually to achieve reduced morbidity and mortality, improved cognitive function, so that we have more productive citizens, so that you can have improved school performance, improved adult stature, reduced obesity, and eventually improved outcomes. If you look at one of the things that has transformed Europe over time, over the last 100 years, I think one thing that really stands out in Europe is that the average height of people has increased by 4 inches over 100 years. And if you look at many of the other outcomes of life, I mean, they have better life expectancy, very low birth weight statistics, and excellent indicators of health. Japanese are naturally short, but low birth weight is extremely rare in Japan. If you look at Scandinavia, you find the same thing. And so you find that areas where you have malnutrition are areas essentially which can be described as developing world. And I think unless we as a whole, as a country, emerge together out of this vicious cycle of malnutrition and underdevelopment, underperformance, malnutrition, we will never really come successfully out of our current situations. So in conclusion, the impact of malnutrition may persist in individuals and families for many generations. In managing malnutrition, we must start where the patient is. Always consider the birth weight before you describe your intervention, and tailor the body mass index accordingly. So the babies who are born with microsomia, the aim should be to keep them from gaining weight in their childhood and young adulthood. While those who are born low birth weight should never gain too much weight in their childhood or later on. Prevention of malnutrition is a multi-pronged, multi-layered effort requiring many players, individuals, families, health professionals, communities, and governments. Thank you for your attention.